Hi friends, I'm Dr. Gurmeet Singh Basan, and in this video we are going to solve another types of problem in which a rod revolves about its midpoint and how the movement of the point on it should be traced out. In my previous videos we have already discussed about basics of Archimedes spiral, solving its simple examples and also examples related to oscillating link. Now, let us start discussing with more application examples of the Archimedes spiral. Now, let us take an example. Rod AB 100 mm long revolves about its midpoint M in clockwise direction for one convolution. Meanwhile, point P initially on A starts moving towards B and reaches B with uniform velocity. Draw the locus of point B. Now here it is moving in a uniform velocity, so it is the Archimedes spiral. So what is given? Rod AB is 100 mm. It's moving from A to B, that is from one end to the other end in one convolution and in the clockwise direction. So this is the data, and now we are going to solve this example. Draw a line AB equal to 100 mm. Mark point midpoint M and complete the circle. Okay, now let us divide the circle into number of equal parts. Say we divide this circle into 8 equal divisions. Now as we know that the rod is rotating in the clockwise direction, we have to give the numbering also into the clockwise direction, that is A1, A2, A3 up to A8. One thing which is very important for these type of example is that when any rod is moving about its midpoint, then it is always necessary that to give the numbering of the other end also, and that would be easier to understand the example. How we can solve it, we can do it later on also. So give the numbering of the other end B. So B is also rotating in the clockwise direction, so give the numbering B1, B2, B3 just opposite to the A1 is B1, A2 is B2 and so on. So here the numbering of the other end is very essential to solve the example. Okay, so we divide the circle into 8 equal parts. So again we have to divide the linear motion of AB also into the same number of equal divisions. Here we divide this AB also into the 8 equal number of divisions. Okay, now let us start drawing the Archimedes spiral by projecting the points. Now take M as the center, radius equal to M21, draw an arc which is intersecting MA1 at point P1. Okay, similarly take center at M, radius equal to MA2, draw an arc which is intersecting MA2 at point P2. Same way we can go for the P3, and we have the point P4 which is at the center. So up to here I think anybody can draw the Archimedes spiral, but the difficulty arises after the fourth point. So here the other numbering should come into the picture. Okay, so the trick is to getting the point P5, we have to see that from the center on which direction the point is moving. So here point A is moving from A to B and midpoint is M. So from midpoint we see that it must be going towards the B side. Okay, so here at midpoint we have the A4 and B4. Okay, now after A4 and B4, next step is we have to go towards the B side as the end point is B. Okay, so to get the fifth point we have to take the point B5 into the consideration because we are going towards the B8 side. Okay, so this is very essential, otherwise you will be confused on which side we are going. Okay, so here from midpoint we check on which direction it is moving. So as the link is point is moving towards the B side, we have to take the point on B5 rod position. Okay, so from 5, draw an arc to MB5 and we are getting the P5. So this is the most important point while we are drawing the Archimedes spiral for a rod which is rotating about its midpoint. Okay, so P5 is here and P6 will be on the MB6. So draw an arc from 6 taking center at M, we are getting the point P6 on MB6. Okay, same way from the 7 on B7 position, so that would be point P7 and P8 would be the last point on the B side. So from here also we can identify that the last point is going towards the B point. Okay, so join all these points with the smooth curve, we are getting the Archimedes spiral. So this is the very nice concept, that after the midpoint on which side we are going. So to understand that more easily and more thoroughly, we have to take the another example for this. Let us take the another example in which rod AB is 100 mm long, revolves about its midpoint M in clockwise direction for one convolution. Meanwhile, point P, initially on A, starts moving uniformly towards B and reaches the midpoint M and comes back to A. Draw the locus of point P. So here rod AB is 100 mm is given. The movement of the point is from A to midpoint, and from midpoint it comes back to its original position of A and in one convolution, and it is moving in the clockwise direction. Okay, so here up to the half of the way our method remains same. Draw a line AB equal to 100 mm, find out the midpoint and complete the circle. Okay, divide the circle into number of equal divisions. As the link rotates in the clockwise direction, give the numbering A1, A2 in the clockwise direction. As I said that the link is moving about its midpoint, then in this condition we have to take the positions of the endpoint also. So that is B1, B2, B3, B4 up to B8. So we are taking the corresponding points of both ends, that is A as well as B, for all the 8 different positions of the link. Okay. Now we have to divide the total linear movement into the same number of divisions. So here the total linear movement is from A to M and come back from M to A. So as we divide this rotary motion into 8 parts, so we have to divide A to M into 4 and again M to A also into the 4. So total 8 division will be there from the starting to the end point of the point P. Okay, so divide this A to M into 4 equal parts and give the numbering 1, 2, 3, 4, and again on the reverse side 5, 6, 7, 8 will be the again end point. Now the method is the same of the Archimedes spiral. So take center at M, radius equal to M21, draw an arc which is intersecting MA1 at point P1. Okay, repeat the same procedure up to the point 4. From 2 we are getting P2, from 3 we are getting point P3, and point 4 will be the midpoint at 4. Up to here I say that the method is simple. Now again remember that from midpoint on which side the point is moving. Okay, so here from midpoint, as we know that it is moving towards A side. So as I told you in the previous slides also, that from midpoint it is going towards A, so we have to take A5 into the consideration. In the previous slide it is moving towards B, so we are taking B5. Okay, so I think you can understand easily how to solve the example when it is moving from the midpoint. So here in this example it is moving back to A, so we have to consider as A5. Okay, so on MA5 from the 5th point taking center at M, we draw an arc and we are getting point P5. Okay, so 6 must be on the MA6. So from 6 taking center at M, draw an arc, which is intersecting MA6 into point P6. Okay. Similarly, from 7 we are getting point P7, and P8 will be the A point, that is the back point to the A. Join all these points with a smooth curve. We are getting the Archimedean spiral. Okay, so I think now this method is very easy, and its trick is also very easy to understand. So again, we go for another example so that you can have a better idea and better concept of how to solve these type of the examples. So here in this case, rod AB 100 mm long revolves about its midpoint M in clockwise direction for one convolution. Meanwhile, point P, initially on A, starts moving towards B, reaches B and returns to A in one convolution of the rod. Draw the locus of point P. Okay, so here what is given? Rod AB is 100 mm. Now remember that it is moving from A to other end B, and from B to again to its initial position A for one convolutions of the rod. So in one convolution, the point reaches from one end to the other end and come back to the original position, and it is rotating in the clockwise direction. Okay. Now draw a line AB equal to 100 mm. Find out the midpoint N and complete the circle. Okay, method is almost same what we did in the previous slides. Now divide the circle into number of equal divisions. Okay. Now as it is moving in the clockwise direction, give the numbering also into the clockwise direction. So that is A1, A2, A3, A4 up to A8. Okay. I'll repeat it again also. As the link is moving from its midpoint, so the hinge point is M, that is the midpoint, we have to give the numbering of the other end also. So from B end also we give the numbering from B1, B2, B3 up to B8. Okay. So as we divide the rotational movement for one convolution into 8 equal parts, so we have to divide the total linear motion also into the same 8 equal number of divisions. Now what is the total linear movement? That is from A to B and from B to A. So that is A to B and B to A should be divided into 8 parts. So we are dividing A to B into how many equal parts? 4 equal parts. And 4 again from B to A. So here we are dividing this into 1, 2, 3 and 4. Okay, and fifth will be onwards towards the A side. 5, 6, 7 and 8. Okay, so it is uniform, that is the rotary motion as well as the linear motion has a equal number of divisions. Okay, now let us start drawing the Archimedean spiral by taking the different points. Now taking center at M, radius equal to M to 1, draw an arc which intersect MA1 into point P1. Where is point P2? That is at the pole point. Okay. Now here also see on which side we are going for the third point. Okay. Now from the second point, on which side we are going? We are going towards this side. So third point is towards B side. Okay. So we have to take the point on the third, that is on B3 side. Remember, okay, the procedure is the same. So from the midpoint, check on which side the point is moving. So it is moving towards the B side and the third point is here. So we have to take the point on the B3 side. Okay. So from third, taking center at M, draw an arc which is intersecting MB3 into point P3. Okay. I think you can understand how it is to be drawn. Now where is P4 point? P4 will be the end point here, that is P4. So that means halfway we have gone it. Now in the another half we have to go it. Okay. So from here again we have to take the fifth point. Now where should be your fifth point? So from B to half of the point we have to take the B5 here, that is point P5. B6 will be here, that is at M here. Now from the midpoint, now tell me on which side we are going. We are going towards the A side. So we have to take the A7 point. Okay. So as we are going towards the A side. So A7 will be here. So P7 will be point here. And where is your P8 point? That is the end point here. That is our P8 point. Join all these points with a smooth curve. So the two curves, they are overlapping each other in this particular example. Okay. So I think by these three examples, I think you must be knowing about how to draw the Archimedean spirals when the link is rotating about its midpoint end. So friends, in this video we have solved three examples having movement of the point from one end to other end, from one end to the midpoint and back to its initial positions, and one end to other end and return back to its initial positions also. There are so many ways the example can be asked depending upon the movement of the point on rod, irrespective of the number of convolutions. So now friends, I am sure you are aware of these methods to draw the Archimedean spirals, and I think you can solve any examples related to these types of things. For example. Thank you.